Hi, folks. This is Nate Crawford broadcasting to you live. At least that's what I'm hopefully is going on, at least with the audio. Make sure I scoot up a little bit closer here. All right, so just as a quick little live tutorial here, and this is a good example of the kind of interesting things you could do with Coulomb's law. So let's take a moment, and we've got the scenario right here. So we've got two pellets. Each pellet has a charge of 1.3 microcoulombs. And so here you see it in parentheses, which that is 0.0000013 coulombs. That's how small that charge is. And these two pellets are located 2.4 centimeters or 0.024 meters apart. And the question is, what is the electric force between them using Coulomb's law? All right, so let's give this a go. Let's give this a go here. All right, Coulomb's law, first of all. A lot of times this is given to you whenever you see a question like this on the exam. So here, let's go ahead and write it out. So the force, according to Coulomb's law, is going to be equal to a constant times the charge of one of the pellets times the charge of the other pellet. So Q1 and Q2 divided by d squared, which is the distance between the two objects. And so what we're going to do now is set this up because we weren't given C in this case. C is that constant. So what we're going to do is just take you part of the way through the answer. And if you're more interested in learning how to solve these with a little bit more detail, always feel free to give us a call or contact us at the group inbox of genedphysics@wgu.edu. All right, so the setup. Now, again, we're not calculating the actual force because that constant C actually does correspond to a real number, but we're going to set this up for you. All right, so each one of these charges, they have the same charge, 0.0000013 coulombs. All right, so both of them have the same charge. So this might seem a little long, but it's good to do this because it's a good habit. So let's put the other charge over here, 0.0000013 coulombs. Now you could just square them since this case, they're equal to each other, but I'm writing this out because this is good practice, right? To make sure you're not missing one, make sure. All right, now what we've got to do on the bottom, we're going to plug in the distance, right? That distance right there. So it's going to be 0.024 meters. But what's really important here, and I'm even going to use a big, huge red right there so you'll remember, you've got to square that distance. That's one of the most common mistakes that I've seen whenever I work with students one-on-one or whenever I was teaching in the traditional classroom. Whenever you have an inverse square law like this, and Coulomb's law is an example, you have to be very careful to square whatever's on the bottom, that inverse square part. So in this case, it's distance. So distance squared, and that's really important to do. All right, now the big thing to remember, right? So this is set up only. If you want an answer, feel free to get in touch with me or my colleagues to help you out with that. But what you need to look for whenever you have an answer is your final units. Since this is force, right? We're calculating a force. So the units are going to give you newtons, right? That's what you're looking for. So your final units are going to be in newtons. So a lot of times whenever you go through a calculation, maybe on an exam, who knows what type of question it might be, it's important to pay attention to what the units are because you might see answer choices that have identical numbers, but the units are different. So you need to make sure you're dealing with make sure you know what units you're looking for. And since we're talking about newtons, we're talking about force. Now, how did I know that that's what I'm looking for? What is the electric force? Right? Looking at those keywords, All right, so this has just been a brief live session to help you out and help you get started with Coulomb's law. Best of luck as you're having fun with this. And if you need any assistance, feel free to contact either me or my colleagues at genedphysics@wgu.edu. We're always happy to help.